Hello, and welcome to CNET 204, Introduction to Web Design, Week 1. This week we're going to look at an introduction to AWS, Amazon Web Services in the cloud, which might seem like a funny place to start in an Introduction to Web Design course, but as we progress through today's lecture, you'll understand why we're starting here, and it makes a lot of sense. Here's everything we're going to go through today. You're going to learn about me because I haven't really introduced myself yet. I was saving that for the next slide. We're going to do a look at the course overview, what you're going to learn, how you're going to get marks, and we'll look at the course outline a bit in depth. And we're going to talk about different types of cloud things, cloud architectures, cloud-based services, the different popular cloud providers. And then we're going to talk specifically about AWS, which is what we're using for this course, and you'll see why a little bit. Just bear with me. So my name's Jason Carmen. I'm a professor here at Centennial College. I'm also a professor at Seneca College. If you need to get an email or get a hold of me by email, there's my email there on the screen. It's also in eCentennial in a couple different places. And you should have looked through the introduction module, orientation module. That's what it's called. You should have found all that information there. If you haven't, you might want to go back and look at that orientation stuff because it's important. I mentioned I also teach at Seneca, and I do teach a variety of different courses at Centennial as well. So if you need to get a hold of me, please include your course code in the subject line of the email so I can get back to you a little quicker and configure out the context of what you're asking as well. That's me on the in that picture on the screen there. I figured it was useful to put a picture in because this is a fully online course, and so we're not going to be seeing each other face to face. But if you see me on campus, I'm obviously not formally dressed like that every day, but I do wear a kilt every day. I'm the only professor on campus who wears a kilt, with sometimes a braided forked beard and sometimes not. With the mask, it's been difficult to do that. Feel free to come up and say hi and introduce yourself. I've been teaching at Centennial College for a long time, since 2016. I was actually hired to teach this course, and I taught it with its original content that I inherited for a couple of years. I rebuilt that in 2018, and I'm now rebuilding that again. So this is exciting. It's all new content. We're going to build our own server in the cloud. We're going to do all kinds of crazy stuff and tie it all together. It's going to all fit together, trust me. Yeah. A little bit more about me. I did want to talk a little bit more about me because I mentioned I teach at Seneca as well, right? So I teach at Centennial. I teach web design. I teach Microsoft Office. So if you have that this semester, you probably have me for that course as well. And I've taught a variety of different Cisco courses at the college. And at Seneca, I teach mostly Linux, but I could teach anything in the networking diploma. I'm actually a graduate from the 3-year networking diploma at Seneca, so I know the infrastructure there very well. And while I've been teaching here for quite a few years, so I know the infrastructure here very well as well. I also remember what it was like to be a student, so I always try to keep that perspective in mind. It's important. So the way this course has been designed, all of the labs build on each other, and the assignments actually integrate with them as well. The labs and assignments can be kind of broken into two parts, but you're learning everything in the 10 labs and 2 assignments to, the 10 labs and the first assignment to build a website, including all of the infrastructure to host it. And deploy it, which is really awesome. We're gonna learn just enough AWS and the cloud, and just enough Linux to spin up an Apache web server in AWS in the cloud. And then we're going to set up our local development environment using Git and GitHub and Visual Studio Code, which is awesome. I really like Visual Studio Code. I used to use Notepad++ for a long time, and I've, as of recording this anyway, recently, within the last 6 months or so, started playing around with Visual Studio Code, and I love it. We're also going to look at DNS, enough for you to actually register a domain name and map it to your web server that you create in the cloud. And you're going to get to do this for free, which is awesome. It's not going to cost you anything. And then we're going to build a website. We're going to build a website using Visual Studio Code as our editor, and we're going to push all our code to GitHub and then pull it into the server we spin up in the cloud. It's going to be all awesome. But we're going to build that using HTML5, CSS3, and a little bit of PHP right at the end, just to make it a little more interactive and awesome. Our website's going to be mobile friendly. It's going to be responsive, so everything's going to resize as much as possible based on the size of the device. It's going to have a very modern feel to it. It's going to be a lot of fun. And most importantly, there's no textbook for this course. Everything in this course is completely free. And in fact, most of the things that we're using are free and open source. You're going to get to register some free domain names and stuff, which is pretty awesome. Now that we've covered that there's no textbook, because that's one of the first questions we get in the course, first day, or first questions I get. How are you going to get marks? Well, it's also on this slide. There's 10 labs, 4% each, for a total of 40%. And as I mentioned, those build on each one. Each one builds on the previous one, so you can't skip any. There's 10 quizzes. Each one of those is based on one of those labs. Quiz 1 based on lab 1, quiz 2 based on lab 2, and so on and so forth. Worth an additional 20%. So just by doing the labs and the quizzes, you've more than passed the course. And then there's 2 assignments. Assignment 1 is actually going to integrate perfectly in with the 10 labs and add some additional functionality to the website that we're building. And then assignment 2, right at the end, you're basically going to build another website, only deploy it in an even more fun way, where we're not even using a server. We're going to use some cloud-based services to do this, which is pretty awesome. I know I've said it's awesome, but I'm really, really excited with the new content that I've built into this. I think it's going to be really fun. Learning should be fun, right? I remember I was a student. It's got to be modern, it's got to be relevant, and it's got to be fun. So let's try to have a good time. If you ever have any questions, ask, and I'll do my best to help you out. Before we move on, I wanted to look at the course outline briefly, at least the important segments of it, because everybody skims over this thing, but there's a few segments that are worth looking at. So if we scroll through, there's our, oh, look, there we go, there's our breakdown. Honestly, the easiest way to get a very good grade in this course is to do the labs, because they're going to teach you everything you need to know to get the remaining 60% of the grade. Just do the labs. It's the easiest way to get an A. Show up, do the labs, you're going to get an A with me. So here's our weekly breakdown. I've split up the lab submissions into 2 halves. So the first 5 labs of the 10 are going to be due in week 7. Now, does that mean you should wait until week 6 to start them? No, you should not, because there's going to be some quizzes as we scroll through this that are based on the labs, right? I mentioned there's quiz 1 based on lab 1 and so on and so forth, right? But they're offset a couple weeks. We're going to use W3 Schools. We're also going to use, I've got a lab site that I've built that, well, I won't spoil the fun, but you're actually going to learn all of the technologies I use to build it in this course. All of it, pretty much. Uh, so lab 2, 3, and quizzes pop up starting in week 4 because students could enroll in this course up to week 3. So quiz 1 based on lab 1, and 5 due in week 7. 6 and through 10 are due in week 13. Again, don't wait until week 12 to start them, right? You should be doing them in the week they're allocated here because it's going to map to the lecture content. And it'll map to the quiz. Like, you'll be fine if you do that. You notice there's 2 assignments and there's no midterm or final exam, right? The assignments are kind of in place of those, and the first assignment's in week 9, where we're going to look at the WAI, the Web Accessibility Initiative. You're actually going to research and implement it. You're going to register a free domain name. You're going to generate an TLS SSL certificate for free, and you're going to add the configuration for your Apache server so you can serve your pages using HTTPS, which is, I think, going to be a lot of fun. Week 10, we're going to learn about, or Lab 10, Week 11, we're going to learn a little bit of PHP, just some intro stuff to process a form. And then the last 3 weeks, we're going to look at Assignment 2, where you're going to plan, implement, and publish a website. And you're actually going to automate the deployment of that website using some cloud services through GitHub. It's going to be pretty awesome. So Assignment 1 in place of a midterm, Assignment 2 in place of a final exam. So there's no major tests in this course. Everything is hands-on. Hopefully that sounds good. I would usually ask at this point, but it's a video, so it's kind of a moot point to ask. But hopefully that sounds good. So, now that we've gotten all of the administrative stuff out of the way, let's start by talking about what is the cloud. You've probably heard this term or used this term, but what is it really? Well, just like anything, ask 5 different people their opinion on something, get 5 different answers, right? Well, we're going to look at 4 different definitions here. We're going to start with AWS, Amazon Web Services. They define cloud computing as the online delivery of IT resources over the internet with a pay-as-you-go pricing. So instead of buying, owning, and maintaining your physical data centers and servers, you can access technology such as computing power, storage, databases on an as-needed basis from a cloud provider, like AWS, right? They had to throw like AWS in there. There's a couple of reasons that we're using AWS, which I'm going to talk about later. Next up, I consulted Azure's definition from their documentation because they're the second biggest cloud provider, as we're going to look at in a little bit. And simply put, cloud computing is the delivery of computing services, including storage, servers, databases, networking, software, analytics, intelligence over the internet to offer faster of innovation, flexible resources, and economies of scale, which they don't really go into define here, but they talk about that a lot in their curriculum. You typically only pay for the cloud services you use, helping you lower your operating costs, running your infrastructure more efficiently, and scale your business as needs change. Google, who was ranked number 3 in cloud, defines cloud computing as the on-demand availability of computing resources, such as services over the internet, computing resources as services over the internet, right? Because everything in the cloud is as a service. It eliminates the need for an enterprise to procure, configure, and manage resources themselves. You only pay for what you use. We're going to look at one more, and this one's from Ubuntu, and that's because that's the Linux distribution we're going to use in this course. Ubuntu defines cloud computing as the on-demand delivery of IT resources over a network. In traditional data centers, compute and storage resources used to be allocated manually by a team. In the cloud, it's fully automated, leading to increased agility and significant savings. So we got four different answers there Uh, but really, let's try to look at the takeaways from each of those, right? Where do they agree? Well, uh, it's online. It's on the internet. Uh, Using a pay-as-you-go, right? You're only paying for what you use. If you're a company or you're starting, maybe you're an entrepreneur, uh, you don't have to buy all the equipment, right? You just sign up for an AWS account or an Azure account or a Google Cloud account, and and spin up what you want. They've got all the stuff there, and they just send you a monthly bill. So you don't have to do all that initial investment and configuration. In theory, if you're a really small business, one person can do the whole thing. And in fact, you're going to learn how to do the whole thing. You're going to learn just enough cloud to build a web server in the cloud and build a website on that. And you're going to build all of the underlying stuff. Isn't that pretty awesome? I think it's pretty awesome. So now that we've talked about the cloud, we should hopefully have a rough understanding of what the cloud is. Let's talk about a couple different types of cloud architectures, because there's a couple different models we use here. First up is the public cloud. Simply using a public cloud, you're using a public cloud provider. So all of the services that you're using are hosted in a remote location that you don't really know where it is. It's just accessible on the internet through that cloud provider. You don't have really any control over the security or upgrading the hardware or anything. It's just you pick stuff from a list or from a menu. You say, I want to spin up this and this and this and this, and boom, there it is, right? You pay for what you use, and it's a common way of doing things. The trick with public cloud is securing it, and we're not going to touch on that a huge amount in this course, but we're going to touch on it just a little bit, because it used to be, once upon a time, as a sysadmin, you didn't really need to worry about security. Someone else came along and did that. But as things have migrated to the cloud, it's now part of your job as a sysadmin to think about security as part of your configuration. So we're going to do that. Popular public cloud providers have AWS, it's Amazon Web Services, Azure, and Google. They're the big three. There's others out there, but they're the big three. Private cloud is pretty much the opposite of that. So services are hosted on a data center that your organization builds. So you've got full control over it, which is great. You can deal with security updates and patches and upgrading the equipment to meet your needs. The downside is you have to build and maintain it. So you have to pay the costs, the physical costs for all the hardware. You have to pay for the staff to build it out, because you're probably not doing it all yourself. And you have to pay for somewhere to put it all, right? Because data centers are pretty big. You can't just put one in your basement. There's a whole bunch of different services you can use out there to host your own private cloud. OpenStack used to be a really big one. It's not as big anymore, but it's a completely open source, top to bottom cloud deployment. So you pick your different modules that you need and you build your cloud with it. It's free, it's open source. It's pretty cool. There's other ones out there too, but OpenStack, yeah, if you haven't noticed, I like free and open source, right? Those two things aren't always mutually inclusive, but open source software tends to be more secure and just run a bit better, but not always. So now we've talked about public cloud, we've talked about private cloud. Next up, we've got hybrid cloud. Hybrid cloud's just basically you got some stuff hosted in the public cloud, some in the private cloud, and you're using both, right? You could also be using two different public cloud providers and be transferring data and balancing data between those resources in those different public cloud providers. Why would you do that? Well, maybe one's got better optimization for, or better offerings for the thing that you want to use. Hybrid cloud is pretty popular. because you could have your own on-premises stuff, not even in a data center, just old school on-premises servers. That's one of the uses for this, right? Where you're beginning to migrate your stuff to the cloud. So you've got your on-premises servers. You start to put some stuff in the cloud and slowly transition things. Hybrid cloud gives you the best balance. So it's gives you the most control about the security for the things that you want to worry about, but also for the things that you don't really care too much about the security. You just want to offload that stuff to the cloud and pay for what you use instead of having to pay to spin up the servers on your own premises to deal with it. You can do that, right? You just outsource that stuff to a public cloud provider, and you don't have to run a server for that anymore because it's a service running in their cloud. It's pretty awesome. So now that we've talked about all those, there's also different implementations of cloud-based services. Usually when you move everything to the cloud, you tend to hear as a service thrown around a lot, right? And I'm going to do that just a little bit in this semester when we start dealing with things in the cloud. Everything's as a service. But they tend to fit into these different modules, or models. So on-site things, right? That's kind of what we're just talking about, on-premises or on-site. You control everything. You, the organization, controls absolutely everything. So you control the applications, the data, the operating system, all of the programs and software needed to run the operating system. If you're doing any virtualization, servers, storages, or networking, that's all in your on-premises stuff. You have to set it up, you have to maintain it, you have to update it, you have to patch it. It's a big job, right? Costs a lot of money. This is the way everything's done. In fact, if you go far enough back, pre-virtualization, we just used to straight up use servers for all this stuff, right? Infrastructure as a service, IaaS, that's where the networking foundation is provided for you. You just have to install your operating system, applications, and configure it. Examples of this, we're going to use one. AWS, that's why I threw it up there first. Amazon Web Services. Also Microsoft Azure. And the cool thing about this is, yes, you do have to install the operating system, but you will, probably not yet, but you will install operating systems. Maybe you've installed an operating system before, and you know it takes like half an hour, maybe a bit more, to sit and install an operating system. And if you need 20 servers, you can imagine that's going to take, well, 20 times half an hour. That's a lot of time, right? Not when you're using the cloud. You spin up an instance in the cloud. That's what we call virtual machines in the cloud. And it takes you like a minute or two. It's insane. And you can actually specify, oh, I want 15 of these exact same configured instances. It takes the same amount of time to do all of them. A minute or two, boom, they're all built. It's great. So that's infrastructure as a service. Platform as a service, you just worry about your data and your applications. Everything else is taken care of by the cloud provider. So we could use AWS Elastic Beanstalk or OpenShift by Red Hat to do this. There's other options out there. Azure has some stuff too, right? I didn't want to overburden you with a whole bunch of different examples of this. But you just build your application and stick your data there, and it does the rest. You don't have to worry about anything else. This usually uses a container of some sort. We're actually going to be using some container based cloud services. We're not going to be configuring much with them. Well, you kind of will in your second assignment. We'll talk about that when we get to your second assignment. But you're not going to have to do a whole lot. And then there's software as a service. So this is software that's provided for you, and you just straight up use it. So things like Microsoft Office 365. You've used that. That's software as a service. Zoom or Microsoft Teams even, right? Those are their software as a service. The service provider does everything with those, right? You just use it. GitHub Codespaces is there as an example because we're going to use GitHub Codespaces in this course, and it's a pretty awesome thing. We'll talk about that in week 4, but if you're curious, you can go look it up. It's actually pretty cool. So our big three in cloud providers, we've got AWS, Azure, and Google Cloud. AWS is the oldest one. They launched in 2006, and they're also the biggest one. They have the biggest market share. Although Azure is quickly creeping up. And in fact, depending on when you're watching this video, because I don't know when I'm going to be re-recording this video, these might be out of date, and you're going to have to look at the updated link there to see if Azure's caught up with AWS. But AWS has been popular for a very long time. AWS was originally built as a platform in 2002 in its initial incarnation when they launched their first web services and they opened the platform to developers. And then a couple of years later, they decide, oh, we want to expand this. They want to expand this, and they expanded it to host their own internal services. And then Amazon, doing what they do best, said, hey, wait a second, we can make some money off this, right? That's what that Bezos dude does. So they opened it up to everybody, and in 2006 started, offering access to host your applications and your infrastructure in AWS to people for money, because it's Bezos. He doesn't do anything for free. Now, Azure has been around since 2008. That's Microsoft's offering, and they're pretty solid. They do a lot of stuff very well. Google Cloud, pretty small market share, right? Only 10%. They've been around since 2008 as well. This is one of the weird places on the internet where you look at Google in any kind of ranking, and they're number 3. Usually they're number 1, right? We're going to be using AWS, and that's because it's the most popular, but B, it has the best support for Linux, and we're going to be using Linux servers. So, because you can leave a Linux server up for years and it'll still work. Plus, it's free and open source. So, since we're going to be using AWS, let's talk about it a little bit. Let's learn a bit of stuff about AWS. So again, I consulted Amazon. What is AWS? Well, Amazon describes AWS as the world's most comprehensive and broadly adopted cloud offering, with over 200 fully featured services from data centers globally. Millions of customers, including the fastest growing startups, largest enterprise, and leading governments agencies, are using AWS to lower costs, become more agile, and innovate faster. And that's true. Like, really, we're using AWS because it's the most popular and they have the most up-to-date, best Linux options available. I looked at Azure, and their Linux offerings they didn't have the newest versions of Linux offerings. They were about one release behind, which isn't a huge deal, but you may as well go with whatever has the most recent, right? Now, where does AWS exist? Well, everywhere, right? All the cloud is somebody else's servers. In this case, somebody else's data centers that you're paying to use. So they've got data centers all over the globe, as you can see on the map here. And there's some coming soon there that might be here by now, depending on when you're watching this video. But they're pretty big, right? Now, I mentioned in the first slide, we're using AWS, and everything in this course is free. But I also just mentioned that you have to pay for what you use in the cloud, right? Well, how the hell does that work? We're going to use the AWS Learner Lab. So it's a free with the Learner Lab, you get a free $100 credit for you to use, and that's tied to a particular Learner Lab instance. So when I configure the Learner Lab for our section, you get that free $100. And if you do another course later at the college that uses AWS, they would spin up a new Learner Lab to get a new $100. So it's pretty awesome. It gives us a sandbox environment so we can configure most of what's available in AWS publicly, but it doesn't support everything. It supports everything we need for the course, though. And it's only running when you start it. But it is available on the internet. You have to think about the budget a little bit, and you have to think about security a little bit as you're doing this, right? But don't worry about the budget. Don't be like panicked. Oh my God, I see my stuff's using money, right? It's going to. But if you follow the lab instructions properly, you don't go play around with a whole bunch of stuff that we're not using in this course. You don't just say, oh, I want to go learn elastic load balancing and spin up a whole bunch of instances, and then log in next week and you've got no money left. That's a problem, right? Don't do that. Follow the lab instructions. You shouldn't come anywhere near to using that $100 credit. Anywhere near it. Everything we are building, though, is on the real internet. It's public facing. In fact, after we do assignment 1, you're going to be able to access your server with a fully qualified domain name that you've registered. So, we need to think about security as part of the configuration, right? And I'm going to show you how to do that. So don't worry. Don't be like, oh, I got to worry about. No. You're just going to follow the instructions, and you're going to learn a bit of security in addition to everything. Now, as far as accessing the Learner Lab, you should have received an email invitation in your Centennial College email. If you haven't, you need to let me know as soon as possible so I can resend that email out. But check your Centennial College email, double check your spam folder. If it's not in those locations, let me know. I can just click a button and it goes to you again. And I'll do my best to get to that in a timely fashion. Sound good? All right then. So we're using AWS. We're going to talk about a couple services in AWS that we're going to use. The first up being EC2, which is Elastic Cloud Compute. Realistically, this is where you're going to be spending the most of your time. And there's a definition on the screen that you can pause and read, but I'm not gonna read that for you. EC2 is where you spend the most amount of your time. It's where you do things like spin up instances, which is what we call virtual machines in the cloud. We can spin up or access. I was saying spin up. We can access other services to automate deployment for different options and things like that. We can look at things. We can allocate different services, elastic IPs, which is what they call static IPs. You do that through EC2. We're going to look at that in later in the course in week 3, I want to say. I think it's week 3. My memory is not the greatest. I know we do it later, but I don't necessarily remember what we do in what given week all the time. But I do my best. VPC, or Virtual Private Cloud. So everything we do is in the public cloud, right? But you create your own VPC, and that segregates a section of AWS's resources to your own virtual network, hence Virtual Private Cloud. You've got complete control over everything in that network environment. So you can assign your own IP address ranges, you can create your own subnets, you can configure your own routing tables and gateways, you can set up your own firewalls and security rules. You can also create hardware connections, VPN connections, between your corporate data center and your VPC. So this is where you would be using a hybrid cloud deployment, right? We're going to be doing some networking stuff in VPC, which is pretty awesome. So you need to know vaguely what it is. We're going to do this in the lab this week. We're going to do all of this in the lab this week. Well, not everything that I've talked about today, but a good chunk. So we're going to use public key cryptography as well. That was mentioned right at the start. The most common implementation of this, also known as asymmetric encryption, is RSA. Which is named after its inventors, Ron Rivest, Adi Shamir, and Leonard Adelman. So RSA involves public and private keys. The public key could be known to everybody. It's used for encrypting the message. And then that message is shared with whoever you want in an encrypted format. Uh, sorry, the private key is used for encrypting messages. Something doesn't look right there. Um, Messages can only be decrypted with the private key. So the private key never leaves the server. I think those got flipped when I did some edits here. Oops, my bad. This paired key encryption, this public and private key cryptography, and you can go read more about it there. It's the foundation of all modern encryption. We're going to be using it to generate RSA key pairs to SSH into your instances without a password. And we actually don't have to do much to do that. That's done by default when you spin up an instance. But we're also going to do this to add the ability for GitHub to connect with, or for us to, for us to SSH into GitHub and pull our things in from GitHub into AWS, into our instance. So we're going to have to set up key pairs for that. You're also going to use it in assignment 1 when you're going to secure your Apache web server with TLS SSL, which gives you HTTPS. So up until we do assignment 1, we're just going to access things with HTTP, which you're going to learn more about later in the semester in a couple weeks. But after assignment 1, we're going to be able to access everything using HTTPS. So how do we remote access things? Well, the easiest way, there's instructions on the screen. We're just going to use the SSH command. So in Windows or Mac OS or Linux, you can just open a command prompt. It's called Terminal in Mac OS and Linux because Mac is Unix based, right? In Windows, it's just the command line, right? So you just type CMD. And in any of those, you just type SSH followed by your username at the IP address you're trying to access, and you type the password when prompted, answer yes to any questions it asks you, and you get access to the thing you're trying to access. Now, we're going to be using RSA keys, so we don't need to enter a password. We add an additional option with the SSH command that says, here's the key, here's the path to it, use it, and that provides all the login information you need. RSA keys are a little bit more secure than having a password set, so that's why we do that, because you can only log in if you have that key, right? Nobody can brute force your password because there's no password to brute force. Now once you're logged in, you're going to do a bunch of stuff in the lab on your AWS instance, and eventually you're just going to want to log out, right? You could shut down everything, but that's not an ideal way to do this. You should log out first before you shut down the learner lab, and you can do that using the exit command. Just type exit or log out, or hold down Control and push D, and that will get you out. So in lab 1, we're gonna access the learner lab. It's the first thing we're going to do, and you're going to get a recording in well, it might be a few minutes for me, it might be a few minutes for you, but you're going to get the next recording you watch is going to be me doing this. So I'm going to walk you through it. You're going to access the learner lab, you're going to navigate the console interface, you're going to configure a couple stuff, VPC and EC2, so Virtual Private Cloud and Elastic Cloud Compute. That's why we talked about those today. And then you're going to create an instance, which is what we call virtual machines in the cloud, and we're going to be using Ubuntu Server for this. And then you're just going to access that instance using SSH. We're not going to do anything with it this week. We're actually going to use it next week when we learn Introduction to Linux. We're going to do that all on our instance in AWS. So, thank you for watching. Take care. Be safe. Have a great day, week, whatever. And I will see you in the next video. Bye for now.